So we've taken a look at Ka and Kb and when those are actually useful. Ka and Kb are useful to us when we're dealing with weak acids and weak bases. But when we're dealing with strong acids and strong bases, we don't need to use Ka and Kb. That's simply because the values of Ka and Kb are so incredibly large, we can actually ignore some of the things going on in the chemical reaction. So strong acids and strong bases are actually the easiest to deal with when we're determining the concentration of H plus and OH minus. We just need to look at the balanced chemical equation, and we need to look at the mole ratios. So if we have a solution of hydrochloric acid, first thing we need to look at is whether or not this is strong or weak. So we look in the table in the data booklet, and we see that hydrochloric acid is a strong acid. No matter whether it's a strong acid or a weak acid, we always start the process the same. We need the balanced dissociation equation, which we can actually take straight out of that table. We have HCl, which is aqueous, which yields H plus and Cl minus. Now, by telling you that the concentration is 0.050 molar, I have told you the concentration of the acid. So I've told you the concentration of HCl is 0.050 molar. What matters to us is what's the concentration of H plus. Well, looking at that chemical equation, we have 1 mole of HCl to 1 mole of H plus, which tells us that the concentrations of both of those will be equal. So automatically we know the concentration of H plus is 0.050 molar. We also know the concentration of Cl minus as well, but it's actually not important to us. Dealing with acids and bases, the only things that make any difference are the concentrations of H plus and the concentrations of OH minus. So this is in fact all we need. We can summarize it at the end if we want to. Concentration of H plus, 0.050 molar.